According to the 2023 National Electrical Code, a fountain that has water common to a pool is considered a pool. This means it must comply with all the electrical provisions set forth for pools in Article 680 of the NEC. The definition of a pool, as stated in NEC Section 680.2, includes any structure intended for swimming, wading, or other water recreation having a depth of 24 inches or 610 millimeters or more at any point. This definition is crucial because it determines which electrical safety requirements apply to the installation. When a fountain shares water with a pool, the electrical systems of both must be integrated and treated as a single entity from an electrical safety perspective. This integration necessitates adherence to the more stringent requirements applicable to pools, ensuring the safety of individuals using the pool and fountain. Some of the specific electrical requirements for pools that would then apply to a fountain with common water include, firstly, bonding requirements. All metal parts of the pool structure, including reinforcing steel, metal fittings, and underwater lighting fixtures, must be bonded together to form an equipotential plane. This bonding helps to minimize voltage gradients in the pool area, reducing the risk of electric shock. The bonding conductor must be sized according to NEC Table 250.122 based on the size of the circuit conductors supplying the equipment. Secondly, grounding requirements. The electrical equipment associated with the pool and fountain, such as pumps, filters, and lighting, must be properly grounded. Grounding provides a low impedance path for fault current to return to the source, causing the overcurrent protected device to trip and clear the fault. The grounding conductor must be sized according to NEC Table 250.122. Thirdly, GFCI protection. Ground fault circuit interrupter, or GFCI, protection is required for many electrical circuits associated with pools and fountains. This includes receptacles within a certain distance of the water's edge, as well as circuits supplying underwater lighting and electrical equipment. GFCIs are designed to detect small leakage currents and quickly de-energize the circuit, preventing electric shock. The specific requirements for GFCI protection are detailed in NEC Section 680.5. Fourthly, wiring methods. The wiring methods used for electrical installations around pools and fountains must be suitable for wet locations and resistant to corrosion. This often involves the use of rigid metal conduit, electrical metallic tubing or ENT, or liquid-tight flexible metal conduit. Direct burial cables must be listed for the purpose and installed at the proper depth. The specific requirements for wiring methods are detailed in NEC Section 680.21. Fifthly, equipotential bonding. Equipotential bonding is crucial for minimizing voltage gradients in and around the pool area. This involves connecting all metal parts of the pool structure and associated equipment to a common bonding grid. The bonding grid helps to ensure that all conductive surfaces are at the same electrical potential, reducing the risk of electric shock. The requirements for equipotential bonding are detailed in NEC Section 680.26. Sixthly, underwater lighting. Underwater lighting fixtures must be specifically listed for use in pools and installed in accordance with the manufacturer's instructions. These fixtures must be supplied by a low-voltage transformer or power supply that provides isolation from the main power source. The maximum voltage for underwater lighting is typically 15 volts, and GFCI protection is required for the low-voltage circuit. The requirements for underwater lighting are detailed in NEC Section 680.23. Seventhly, clearances. Electrical equipment must be located at a safe distance from the pool water. This includes receptacles, switches, and lighting fixtures. The specific clearance requirements vary depending on the type of equipment and the voltage level. These clearances are intended to prevent accidental contact with energized electrical equipment while in or around the pool. The clearance requirements are detailed in NEC Section 680.22. Eighthly, overcurrent protection. All electrical circuits supplying the pool and fountain equipment must be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to protect the wiring and equipment from damage due to overloads or short circuits. The size of the overcurrent protection device must be properly coordinated with the ampacity of the conductors and the rating of the equipment. The requirements for overcurrent protection are detailed in NEC Article 240. Ninthly, disconnecting means. A disconnecting means must be provided for all electrical equipment associated with the pool and fountain. This disconnecting means allows for the equipment to be easily de-energized for maintenance or repair. The disconnecting means must be readily accessible and located within sight of the equipment. The requirements for disconnecting means are detailed in NEC Section 680.12. 10thly, inspections. Electrical installations around pools and fountains must be inspected by a qualified electrical inspector to ensure compliance with the NEC and local codes. These inspections help to identify potential safety hazards and ensure that the installation is safe for use. It is important to obtain the necessary permits and schedule inspections before energizing any new electrical equipment. 11thly, signage. Warning signs must be posted in the pool area to alert users to potential electrical hazards. These signs should include information about the location of the disconnecting means and instructions for what to do in case of an electrical emergency. The specific requirements for signage are detailed in NEC Section 680.57. 12thly, specific equipment. Specific attention should be paid to the electrical requirements of pool pumps, heaters, and other specialized equipment. These devices often have unique electrical requirements that must be followed to ensure safe and reliable operation. Always consult the manufacturer's instructions on the NEC for specific guidance on installing and wiring these types of equipment. 13thly, modifications and additions. Any modifications or additions to the electrical system around a pool or fountain must comply with the latest edition of the NEC and local codes. It is important to obtain the necessary permits and inspections before making any changes to the electrical system. Failure to comply with these requirements could create a safety hazard and result in fines or other penalties. 14thly, training and qualifications. Only qualified electricians should perform electrical work around pools and fountains. These electricians should have the necessary training and experience to properly install and maintain electrical equipment in wet locations. It is important to verify the electrician's credentials and ensure that they are licensed and insured. 15thly, local codes and ordinances. In addition to the NEC, local codes and ordinances may also apply to electrical installations around pools and fountains. It is important to check with the local authorities to determine the specific requirements for your area. These local codes may be more stringent than the NEC in some cases, so it is important to be aware of all applicable requirements. 16thly, voltage drop. Voltage drop in the electrical circuit supplying the pool and fountain equipment must be kept to a minimum. Excessive voltage drop can cause equipment to operate inefficiently or fail prematurely. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law and the resistance of the conductors. 17thly, conductor sizing. Conductors must be sized properly to carry the load current of the equipment they supply. The ampacity of the conductors must be at least equal to the non-continuous load plus 125% of the continuous load. The conductor size can be determined using NEC Table 310.16 and other applicable tables and notes. 18thly, raceway fill. The number of conductors installed in a raceway must not exceed the maximum allowable fill percentage. Overfilling a raceway can cause overheating and damage to the conductors. The raceway fill requirements are detailed in NEC Chapter 9 and applicable tables. 19thly, box fill. The number of conductors and devices installed in an electrical box must not exceed the maximum allowable fill capacity. Overfilling a box can make it difficult to make proper connections and can create a safety hazard. The box fill requirements are detailed in NEC Section 314.16. 20thly, weatherproofing. The electrical equipment installed outdoors must be weatherproof to protect it from the elements. This includes using weatherproof enclosures, fittings, and connectors. Weatherproof equipment is designed to withstand rain, snow, and other environmental conditions. 21st, corrosion resistance. Electrical equipment installed in damp or corrosive environments must be corrosion resistant. This includes using materials that are resistant to corrosion, such as stainless steel or PVC. Corrosion can damage electrical equipment and create a safety hazard. 22nd, surge protection. Surge protection devices should be installed to protect sensitive electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices can help to prevent damage to equipment and data loss. 23rd, standby power. Standby power systems, such as generators or uninterruptible power supplies or UPS, may be required to provide backup power to essential equipment during power outages. Standby power systems can help to ensure that critical equipment continues to operate during emergencies. 24th, energy efficiency. Energy-efficient equipment should be used whenever possible to reduce energy consumption and lower operating costs. This includes using energy-efficient pumps, motors, and lighting fixtures. Energy-efficient equipment can save money and reduce the environmental impact of the pool and fountain. 25th, documentation. Complete and accurate documentation of the electrical system should be maintained, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be helpful for troubleshooting problems and making future modifications to the electrical system. Remember to always consult the latest edition of the National Electrical Code and local codes for specific requirements and guidelines. The NEC is updated every 3 years, so it is important to stay current with the latest changes. By following these electrical safety requirements, you can help to ensure the safety of everyone who uses the pool and fountain. Ignoring these requirements can create a dangerous situation that could result in serious injury or death. So, adherence to these guidelines is not just a matter of compliance, it is a matter of safety and responsibility.